Hello everyone, welcome back to my channel. So in today's lesson we are going to discuss about algebra, as you can see on the board, exponential algebra, which is one of the backbone of general mathematics. So for today's lesson we are going to consider from basics to maybe a bit advanced, but not that much, because we can apply some logarithm and another power rules. But first, you can see here we have basic equation on the board where you can use to solve. If your arithmetic is very good, these ones are just basics. Of course, I'm supposed to start from the laws of exponential, but as we go along, you can see how we use these laws to solve this type of questions. So here with us, the first question on the board, we have 3 sets of questions. The first one says express each of the following in terms of power in base 2. So you can see we have 3 equations. We have the first one A, B, and C. Then the second one says solve each equation by getting a common base. So here again, we are going to consider these variables. Then we'll try to eliminate the common base and find the unknown, which is x. And the third one here on the board says find the value of x for the equation. Here again, it's just similar to this one here, but maybe this one is a bit advanced as compared to this equation, but you can use almost the same. Even though the only difference here you can see, here it's not possible for you to use a common base. Here we can get a common base, whereas for here we can't get a common base. So in that note, if the bases are different, definitely we're going to use different approach to solve such problem. So in this lesson today, you are going to see from basic to maybe medium, and you can see a bit advanced. So let's try this first one here. So the first question on the board says express each of the following in terms of a power in base 2. So our target here is the base supposed to be 2. So of course, which number you think you can multiply that will give you 8 without any remainder for an example? But already the answer is here for the base. They said base 2. So if you multiply 2 by 2 and 2, 3 times will give you 8. So but we need the base. So this one we can say 2 to the power 3. Okay? Because 2 to the power 3 means 2 times 2 times 2, which is 8. So the common base here is satisfied in terms of a power in base 2. So here again, we'll try 4 cubed, which is this one. First, for the 2 is 2. This 4 here, you can multiply twice, 2 twice. So first, consider the base. So 2 is the base. So which number can give you 4 when you multiply? So this 2 to the 2 into 3. So therefore 2 to the 6. Okay, so this is the answer. Then the third one here says with 16 by with 4. So with 16 gives us 4 times with 4 will give us 2. So now we can further break this one. Say 2 to the 2 times 2 to the 1. So since we multiply here, according to exponential law or indices law, you can say 2 will add the power. So 2, this one will be 2 into 1 plus 2, or 2 plus 1. So this 2 to the 3. Okay, so now let's come to the other equation. Here on board, example 2 says solve each equation by getting a common base. So now you see here, first our target here to differentiate the bases, the common bases. So if we consider 2 or we consider 4, then we need to break this equation down so that what number will give us this 64? The base that will give us this 64 is supposed to be equals to this one. If we use 4 or we use 2, 2 to the power which number that will give us 64, then we use this to apply. Okay? So here we can say 4. If we use 4, we can say 4 to the x plus 3 must be equals to 4 to the 3 of x. We'll consider the bases. The bases are the same, so we'll consider this, we'll ignore the bases and we'll use just the power. So this now, the bases are the same, so we say x plus 3, we'll cancel this. Now we say x plus 3 is equals to 3x. We'll transpose x, so we say 3 is equals to 3x minus x. So here 3 is equals to 2x. Therefore our x here is 3 over 2. So this is the answer for this. So let's see again this one here. Our target here is the common base. So here simply we'll cancel this one because the bases are the same. So here again 4 to the 2x must be equals to 2 to the x minus 3. So this one you can simply break this one down into 2. So you can say 2 to the 2 into 2x must be equals to 2 to the power 3 into x minus 3. So this one now becomes 2 to the power 4x multiply must be equals to 2 to the power, we expand this one, 3 times x, which is 3x minus 9. So now the bases are the same. We have the common basis. So we ignore the basis, then we equate these variables and these constants. So now this becomes 4x, this we ignore. 4x will be equals to 3x minus 9. So now if we transpose this one here, we say 4x minus 3x is equals to minus 9. 4x minus 3x is just x equals to minus 9. Okay. So now let's see. This one here is different. This one, the bases are different, and no way you can change these bases for them to be equal. So in that notes, we use 6 steps here or methods we can use to solve short problems. So I highlight this one because you can understand further as you go along. So the first step says you can use log on both sides simply because the bases are different. After which we use the power log of logarithm. Then we use distributive log to expand. Then we move the variable terms. Then after which we use common factors. Then we isolate the variables and get our answer. So let's see here. So first, since the bases are different, so we'll apply log on both sides. Log on both sides. So now we can say here log into this 4 to the 2x minus 1 is equals to, here again, log 3x plus 2. So now if we apply the power log rule here on this equation, so after this step we apply logs on both sides. So now our target here, we apply the power log here. You know we have here power. Logarithm says if you have power, this power will take it as base down here, then multiply by this. So apply power law. Power law of log. So this power law of log, let me just highlight. We take this entire equation here, take it down. Then we take again this entire equation to down here. So now we say 2x minus 1. 2x minus 1 here. We say log of 4 must be equals to x plus 2 x plus 2 here, log of 3. So now we multiply, we try to expand this one. From here, we use distributive law. So distributive law, we take this equation, this variable here with a constant, to multiply to this, and we multiply this to this, then we do the same on the right hand side. So now we can say 2x log 4 minus log 4, yeah, must be equals to this. Again we multiply x log 3 plus 2 log of 3. So now from this point now we can just try to equate the variables and the constants. Okay, here this one has x and this one has x, so we transpose this one with a variable and one with a constant, so we try to find x. So now this we can say 2x log 4 minus x log 3 must be equals to, and you say 2 log 3, 2 log 3 plus log 4. Log 4 here. So now this one you can simply see here. Again, we can further send this one up here. This one becomes 16. So this now is x log 16 minus 4 to the power 2 is 16. So this is 16. This one comes here. Make it very clear. This one comes here. Power rule. Then we say x log 3 must be equals to, then this again becomes log, this one comes here, 3 to the 2 becomes 9, 3 squared is 9, log 9 plus log 4. So now we use the logarithm law that says, let me simply put it here, if you have log of base, which is log of base, log of this b, m, n, let's say m minus n first. So this one will be log m over n. So this one will be log of b into m minus log of b of n. Okay. And again, if we have multiplication, like log of b into mn, this one again will be log b of m plus log b of n. So now we apply this law here to this equation. So we can see here we have minus. So if we have minus, we take this x into log of, we say 16 over 3, then must be equals to this again. When we add here, we multiply now 9 by 4. So we find our x. So this now becomes x log 16 over 3 is equals to, we say log we multiply 9 by 4 because this one, when you add, you multiply. So 9 by 4, which is 36. 36. So now, we want to find x. So we divide both sides by log. We divide both sides by log. X over 3 log 16 over 3 here. And we divide this log 16 over 3. So then we cancel this one here. Therefore, our x is equals to, here we say log of 36 divided by log of 16 over 3. So this one, different way you can get the answer. You can either use this one direct on your calculator, you can get the answer, or you further break down this. This one will serve as the base, and this is your power. So this one is the same as log of 36. Then the base here is 16 over 3 again. So you can plug this in your calculator. Then your final answer here will be 2.14 approximately, because this is not exact. So therefore x is approximately 2.14. So you can check this on your calculator and try to see. Then in the next lesson, I think we have to solve the one that you can use quadratic equation. So on our next lesson, you can see how we can apply this same method in different approach using quadratic equation. So thank you for watching the video. Don't forget to subscribe, comment, so that we can see if you have any further inquiry or the questions. Just drop your comments. Thank you for watching the video.